Okay, so a couple of things I mentioned in the slides about learning theory is the diagnostic semantogenic theory. Okay, that's if you label a child as stuttering, they're going to stutter. Okay, so if you tell a child you're stuttering, that's going to make it worse and then make them stutter more. Okay. So they did a study many years ago that was called the monster study. Did anyone read that yet in the chapter? So basically they did a study where they told children they were stuttering even though they weren't. Okay, and they used children who were in, so that's why they were, why it's called the monster study is because they labeled the researchers as monsters. Okay, so in doing this, so it's very unethical. But way back when, there weren't regulations with research that people were doing, and these were children in an orphanage. Okay, so they took advantage of that, and they used these kids to then tell them, you're stuttering, stop stuttering, even though they weren't, to then see if they really would develop stuttering. Obviously, no. So labeling them, okay, or diagnosing them as a person who stutters, did not have any effect on their development of stuttering. Okay, so that's what. So you can read more about the study in chapter 3. It's interesting, but obviously very unethical. Okay. Okay, so we talked about the behavioral theories. Okay, learning theories. All right, so moving on to physiological now. Okay. So I've mentioned before, okay, they have now done imaging studies, okay, and they've seen, again, here in slide 15, right hemispheric asymmetry. Okay. So there's more activity in the right hemisphere for PWS, people who stutter. Okay. So they've also seen structural differences with CAT scans and CT scans. Okay, so that's outlined in slide 15. Okay. So their theory is, so why is their right hemisphere more active? Okay. They're saying that it's a compensatory strategy for people who stutter. Okay, in that they actually form a Broca's-like area on the right side. Okay, do you remember reading about that? Yeah. To compensate for the lack of development of the Broca's area on the left. Okay, not to say there's no Broca's area on the left, but because it's underdeveloped, okay, maybe on the left, then they've developed that type of ability with the right side, okay, which causes an asymmetry, okay, and difficulty with signaling overall. Okay. Right, so slide 17 talks about that development of the compensation area, okay, in the right side. Okay. So the issue is that then there's a lack of communication then with Wernicke's area, which is over on the left side. Okay, so back to anatomy and physiology that traditionally, Broca's area on the left side is very close to Wernicke's area, right? They're right there next to each other. So it would make sense now that there's communication difficulties for someone who stutters if now they have some Broca's area now more working on the right side, and then signals aren't traveling or coordinating with the left side of Wernicke's area. Okay. Yeah.
If they're having this compensatory like Broca's area, why would they do the same with like the Wernicke's? I just thought I already searched it.
It's a good research question. I don't know. Yeah. It's a good question.
I feel like maybe it's because like Broca's is more expressive and Wernicke's is more like comprehension.
Mm-hmm.
Maybe then? I don't know.
Yeah, and again, they see more of this asymmetry in adults who stutter. So I think it's over time, the brain has developed this neurological difference. Okay. They're still trying to look at children more so, but what the studies is saying is that it's not as prominent in kids. Okay. So I think, like, it goes to what you were saying, in that, you know, the auditory skills are there for someone who stutters, so that area of the brain's still developing. Okay, but again, there's changes in what they're seeing in how the midbrain works with kids who stutter. Okay, and then again, is it related now? Why do more boys than girls stutter? Does testosterone have a play in that development of basal ganglia and the midbrain in boys? Okay, that makes them more susceptible to possibly developing stuttering. So then once stuttering starts to happen, then does the brain naturally take over, right, and develop another area, because for whatever reason, you know, that left side isn't being developed as it should, you know, for expressive communication. So, but all kind of interesting stuff, you know. And again, you know, a lot of this stuff we did not know years ago. Okay, so, all right. So slide 18 gets a little technical. Okay. Again, talking about the basal ganglia. Okay, and so they did a study with hypothesis looking at, again, the structural abnormality to the corticostriatal white matter fibers in the basal ganglia, okay, and then from the primary motor cortex to brainstem projections. Okay. Stuttering is caused by elevated dopamine levels affecting the putamen. So they looked at here differences, okay, in the dopamine, you know, is the chemical that helps with neurotransmission, right? So if dopamine levels aren't where they should be, okay, they're looking at then, is it affecting that neurotransmission, okay, through that brainstem area. So that's what, you know, the researchers were looking at. If they could manipulate that, could they cause stuttering? Okay, they're kind of trying to see what the causes are. So conditions, they said, prevent the function of the syllable sequencing circuit consisting of the basal ganglia, thalamus, and premotor cortex. Okay, we know that's kind of the channel where the neurological system forms in the premotor cortex, right? It goes to the thalamus and basal ganglia, right, for refinement out to the cranial nerves. So do these neural abnormalities then delay the readout of the next syllable's motor program, leading to stuttering, fluency? And so I gave you some illustrations in the video to kind of review your anatomy and physiology, the basal ganglia, there and some YouTube illustrations. So there's more research to be done to kind of look at the chemistry of the neurological impulse, really, and to kind of see is, what causes these different levels of dopamine, okay? The causes then the neurological system to be disrupted, basically, is what they're saying, So, so that's a new study. It's only 2013. Okay, so there's going to be more stuff to come out on the horizon about this, and I bet maybe in your generation they might have some medication, okay, to kind of correct some of this with kids, okay, to then avoid now permanent neurological differences as the child grows. All right, so genetics, chromosomes. Okay? That's kind of the other discussion in this chapter. Okay? Basically, what they're saying is they do see a pattern in families. Okay, they've done studies, longitudinal studies. Okay, they know that we said monozygotic twins tend to stutter more than dizygotic twins. Okay. That would make sense, okay? Because I said if neurologically you have a makeup, okay, that would put you more at risk for stuttering, okay, then a person with that same genetic makeup would be in the same boat, okay? What they haven't really concluded, as they say with slide 23, is that they can't really isolate the gene, okay? So of really what gene mutation, okay, would actually cause development of stuttering. So again, it says lack of consistent findings. So at this point, they're still working on that, but they really can't say, hey, it's chromosome 18, so they really just don't know what the definitive cause is as far as what chromosome might be mutated or have some kind of difference that would cause stuttering. Okay. All right, so they started also looking at how cells metabolize and how this might affect someone's neurological cells, okay? And they started looking at abnormalities in how the cells use protein, okay? And that's kind of what the discussion with enzymes is in the chapter. So they're looking at certain genes that may affect how cells metabolize, okay, and metabolize protein, which they're looking at possibly some type of metabolism issue with kids who might be more prone to stuttering, in that their cells, okay, of the midbrain premotor cortex, Broca's area, okay, are not developing the same, okay, as typically developing kids. Okay. So, it's basically saying, well, what is causing this neurological difference? Okay, and that's what they're trying to put their finger on. Okay, so if it is chromosome X, Y, and Z, okay, what is that chromosome then doing to the person's system, or neurological system or cells to cause them to operate differently? So now they're kind of looking at the cells itself and how the cells metabolize and then reproduce and grow. Okay, so that kind of goes back to, we talked about last week about Barry Guitar's theory of the perfect storm of, what needs to kind of occur for stuttering to develop. Okay, and we said, well, why does stuttering happen at 33 months typically? What's happening at that age? Why doesn't it start to happen, at 6 or 7? Okay, it's because that child's neurological system is in overdrive, okay, to develop speech and language. Okay, so they're saying kids who develop stuttering have a blip there, okay, but what's causing the blip? They're saying, well, maybe it's how their neurological cells are working and metabolizing and being able to reproduce. So, like typically developing kids. So slide 26 kind of sums it up better. It says, with stuttering, the protein is still being made. So maybe the protein's being made, for the cells to still develop and reproduce, but it's altered. And it's uncertain how this metabolic problem influences the central nervous system. So meaning neurological development and structures related to speech. So they're also looking at possible enzyme replacement therapy, focus of therapy for individuals or children who are most likely to be persistent or in the chronic phases of stuttering. All right, so we kind of end the discussion with talking about the multifactorial theories. Okay. And that these theories play the most weight today. Okay. It's sort of kind of summing up all these different things that we've been talking about to kind of say it's not just one thing, it's a lot of different things that can then contribute for a child to then develop chronic stuttering. Okay. Slide 27 talks about some more issues, okay, with the person's ability to monitor phonological encoding, okay, and be able to plan phonetic sequences. But it's not what I'm talking about as far as apraxia speech. Okay, it's not. We saw stuttering. That's not it. Okay, but it's kind of that more smooth, quick signaling. Okay, that you need to have smooth co-articulation. Okay, so you have the phonemes. You know what you want to say. Unlike a kid with apraxia, they may know the word, but then completely different phonemes come out. Okay, so, or lack of thereof. Okay, so they say that people with stuttering may have an abnormally slow rate of phonological encoding. Like I said, they know the phoneme, they know what they want to say, but it's a very slow rate of encoding, requiring them more time to activate a target, resulting in a greater chance of error. So that moment when they're not going to be able to execute the next sound that they want to say, then shows up as stuttering behavior. So there's been some support, they say, in 2008 that children who stutter have difficulty organizing lexical information. And I would completely agree with that in the clients I've worked with, school age kids, in that when I initially started working with them, a lot of times also we were working on narration. And they had difficulty organizing their thoughts and putting together nice, cohesive, syntactically, together sentences. Sometimes it was sentence fragments, and then they would say a sentence, but then they would have to then circle back and then re-clarify. So, I would agree that I've personally seen that as well. Okay, demands capacities model. We'll be talking about that throughout the semester, especially too when we go to treatment, okay? Because the multifactorial views have then have spun off our treatment theories, okay? And so the idea with the demands capacities model is that stuttering can worsen and possibly become chronic, okay, if the child's speaking demands are exceeding their capacity. Okay, it's not anything complicated. That's basically what it is. The demands capacities model, meaning that the child's speaking demands, and it's not saying that the parents purposefully putting high speaking demands. It's just for that kid. These speaking demands that they're in are too high for their motor capacity to produce speech and smooth speech and language. It also can relate to just, again, their overall expressive language abilities at the time. Like again, the previous slide said that, children have difficulty organizing lexical information. So again, that relates to their capacity. If they're in a higher demand to try and communicate information with higher lexical information with the right syntax, then there might be a breakdown, okay? And then that would fuel the fire for stuttering. So with the capacities here, again, I talked about, motor. So the child may have some mild motor delays, okay, with co-articulation, with speech production, and linguistic delays, like I mentioned. They also may have more reaction to social emotional distress, okay, or situations. And also they mentioned cognitive, but it's not anything with intellect, okay? It means that the child has more difficulty communicating in different situations effectively, okay, to know how to be a good communicator. Breakdowns in any of those areas, motor, linguistic, social, emotional, cognitive, okay, can then lower the child's capacities, okay, to communicate in higher demand situations. So that's the demands capacities model, okay, which then can equal increase in stuttering. So they also mentioned, again, we talked about environmental demands over here, okay, on this side, the causes. So besides internal, I talked about internal capacities, neurologically, physically of the child, but it also could be, but demands, again, could be also environmental, again, we talked about here, or demands internal, meaning internal pressures the child may put on themselves, okay, to speak. They want to speak perfectly, and they don't like not being fluent. So that also is an internal demand that they're placing on themselves. The child has more of a perfectionist personality, and they don't like having pauses in their speech or not being able to get their word out. that then starts to fuel some internal responses. Okay. So, okay, so just to sum up, last couple slides here. Ode and Couture, they, again, did some overall longitudinal studies, and like I said, they were able to look at some of these more structural differences in adults. Okay, they're starting to see some evidence for this in children, but the last research was 2013. So they're starting again to look more at kids who stutter, with their neurology, but they definitely were able to definitively have evidence of structural differences in adults who stutter. Okay. All right, so the neurophysiological model, they're saying still is the best explanation to date. So it's, again, the perfect storm, okay, among the central neurophysiological processes, okay, the child's ability to output speech, as far as motor, cognitive, language, social, and emotional processes, all of that combined, along with environmental influences. Okay, so they are saying that environment does play a role. Okay. So, in conclusion, they're saying it's a neurodevelopmental epigenetic multifactorial disorder. Period. Any questions?